All right, so for absolute value inequalities, what you're going to do is the same as equations. So solve. There's only a couple different rules. So differences are, so your differences are if you divide, multiply or divide, divide. My I does not look like an I. Usually it's divide both sides a negative, flip the inequality, so that means if you have like you were multiplying by a negative and you wanted to get rid of that, so to move it onto the other side, you divide both sides by it. That's when you'd flip the inequality. If you were just simplifying and you had a negative that you were multiplying on one side without moving it to the other side, then the inequality doesn't change, but that doesn't happen hardly at all. The other thing is that you can't say is just because you have an absolute value and a negative number with an inequality, you can't guarantee um, that you have no answer. So you have to think about it a little bit more. So just because an absolute value inequality has a negative on the other side doesn't mean that you're automatically no solution. There are some special things that we have to look at with that. But otherwise, the big thing is if you're dividing both sides by a negative, flip the inequality. And then in the notes that we have on the Cornell notes is thinking about how you're going to write your answer of with inequalities. We like to use the less than sign if at all possible. We always like to have things in order from smallest to largest. Occasionally, if we can't use a less than, we'll have to use a greater than, and then we put the variable before the number. So just some little things that we talk about. For this one, we are going to look at some of the examples. They are very similar to the ones that we had on the equations. However, they're still different. And we're going to look at maybe most of them. We're going to see how long they take. So starting with the first one, rules are the same. We want to get the absolute value all by itself. And then we think of the number line with the two equations, two inequalities in this case. So +1 on this, +1. And then we have the absolute value of x plus 3 is less than 5. Now, some people remember if you're changing the number, so you're thinking of the -1, change the inequality at the same time. However, I'm not very good with that. I tend to forget some stuff. I distract myself quite frequently. So I still think of the number line. So my first inequality is going to be -5 because I want to be 5 spaces. So this is saying the absolute value of x minus 3 is smaller than 5 spaces from 0. So I'm thinking -5. And I use the same symbol if I'm thinking number line, and I've moved it to the other side. So that gives me the same symbol. And then the other one is going to be an x plus 3. This sometimes makes my answers easier to see of how I want to answer them for the inequality answers. So then -3. -3. I'm still solving them. I'm going to do them all together when we're doing it. So I have -8 is less than x, and then x is less than 2. Now, if I look at what I have written right now, I am using all less thans. I have my numbers from smallest to largest, and x is technically in between them. It's written twice. So this actually is just one answer. My answer I would leave is -8 is less than x and is less than 2. If I was doing it in interval notation, this would be It's doesn't have the or equal to, so it's a rounded bracket, rounded parentheses, -8. And it's going all the way to 2. And I did it without having to write the number line. Cool. All right, looking at the next one, we are going to get the absolute value by itself yet again. So we're going to subtract 11 from both sides. And this gives me 1/2 times the absolute value of 4x minus 4 is less than or equal to -7. Now, we're going to still get that absolute value completely by itself. So we're going to divide both sides by that 1/2. So I have -7 divided by 1/2 is the same thing as -7 divided by 1/2, which is -7 times 2 over 1. So this is -14. All right, so I have the absolute value, wrong button, sorry. Absolute value, I want blue. Absolute value of 4x minus 4 is less than or equal to -14. We're going to see if it makes sense when we're talking about it, when we get the numbers with that negative. Okay, so this, I'm going to use that rule of the switching the signs, thinking about, does this make sense? Can I be fewer than a negative number of spaces? No, because I can't be a negative number of spaces. We're already working at something that's not possible. So this, I'm really thinking, is going to be a no solution. Let's see if we can make sense of it. Double checking. So we have 14 is greater than or equal to 4x minus 4. 4x minus 4 is less than or equal to -14. This is going to be a hot mess that we're looking at. Yeah, so thinking about this reasoning, it's not looking very promising. We could get answers technically, but logic-wise, there's no solution for this one. All right, so this is going to be a no solution if I was using a greater than. So if I was talking greater than a negative amount of spaces, it is greater than something that's impossible to do, which would mean that anything that I do is going to be greater than something that's impossible. So thinking those through, I could get an answer for a greater than. However, we will look at those specific cases when we get them in our homework on Alex. So right now, we're going to leave this one as this doesn't make sense. And it's really going from here. Can I be less than something that's not possible? Not really. So I'm going to say that this is no solution, with the caveat that we're going to look at it later and might have to revise that. All right, so looking at the next problem, we are going to get the absolute value by itself. So plus 3, I have 10 times the absolute value of x minus 4 is greater than 50. Ooh, I like this. This is going to be nice numbers yet again. I was being kind when we wrote these. That doesn't usually happen. Okay, so divide by 10. That gives me, these cancel out. Absolute value of x minus 4 is greater than 5. Put them in order. So -5, change color. -5 is greater than x minus 4. X minus 4 is greater than 5. Get that x by itself, so plus 4. That gives me, we'll do, put that color. -1 is greater than x, and x is greater than 9. If I was looking at this, looking at small least to greatest, I'm not using less thans, so I really want to do each one of them separate. So where that is going to look at, if I was graphing it on a number line, I'm going to put this one actually on a number line, put it up here. So I have -1 and I have 9. They both have open circles. And it is telling me x, it's got the smaller part of the inequality, so it is going this way. And with the x and the 9, x is greater than, so x has got the bigger part and it's going that way. So this is one of those ones that's a gap. When I put the numbers in order, I couldn't use a less than. So math-wise, we would want to write this as using less than. So the variable comes first. So x is less than -1, or the x is first on this one, x is greater than 9. So I like to use less thans. If I can't necessarily use a less than, I definitely want the x to be first. This is how I would write this one. If I had to put it in interval notation, it goes with the graph. So it is a negative infinity. It's got the or, it's going to have a gap. And -1, they're open circles, so they are parentheses, the gap, and then we have 9 and infinity. So both ways that the answers are going to be, they're probably going to ask you for the inequality. Cool. So that's how I determine whether or not I have to use that or if I can mush things together and just keep using those less thans. All right, since we're looking at quite a long video, we're going to put the other two, we're going to work out the things and put them in your notes so that they will be up there, the answer keys. So you try them yourselves, check with the answer key that will be uploaded, and we will answer any questions you have.